it shouldn't be that hard,
Hi, my name is Jack. I'm going to be walking you through the Triboelectric effect as well as the first couple of questions on our electric charges worksheet. Starting with the first question, what does the word atom mean to you? Describe how you imagine an atom and explain why you picture it that way. So to me, I picture an atom to just be an extremely small circle. On the inside, there are two main parts. There are the protons, neutrons, and then in the very center of the atom, there's the nucleus, and the electrons are orbiting around it. This is basically the essential building block of the universe. It's what allows me to stand on the floor. It's what allows my clothes to attach to my body. I can sit in this chair all because the atoms connect with each other and they build everything. Yeah. Moving on to question 2. What is an electric charge?
Hey y'all, I'm Sash. We're gonna talk about the electric charge. So what's an electric charge? Electric charge is an electric property that the particles inside an atom they carry with each other. So what are those particles? We got electron, we got neutron, and we got proton. So what types of charges do we got at first? We got negative and positive. So in these particles, in the neutron, as same as the name of it, it's neutral, so it doesn't got any electric charge. But the other two, for the proton, you got the positive charge, and the electron got the negative. So then we continue to the question 3. Yeah, I'm a colleague here. Going to explain for you all.
My name is Jonathan. I'm going to explain what it means for an object to be electrically charged. What I initially thought, it was just like an object just has a neutral charge, doesn't have any protons or electrons. It's not either positive nor negative. But when I researched it, it means it's for when an object is either gains electrons, it becomes negatively charged, or if it loses electrons, it becomes positively charged. And then when it has either one of those, it creates an electric field, and it either repels something or it'll attract it. That beat from explanation, my colleague can explain the next question.
Hi, I'm Tyler, and the question about can you create an electric charge? At first, I thought that you can, since you can kind of transfer polarity between objects, and after researching it, found out technically you can't create an electric charge due to the law of conservation of charges, but you can make one by transferring electrons from one object to another, such as in our experiment today, we're going to be rubbing a balloon on this hair here in different time increments to see if it kind of has a different effect on another balloon, see if it attracts it more with more rubbing or less with less rubbing.
All right, so while we rub those balloons and charge them up, we'll move on to question 5. Can you create an electric charge? Technically, no, but yes at the same time. Alright, and then following up with the last question, are electric charges and energy the same thing? If not, what are the differences between them and in what ways are they related? So no, they're not the same thing because they deal with different processes in physics. Electric charges have to deal with protons and electrons as well as neutrons and...
Yeah, I think we'll show all of them.
I'm gonna have to cut that too. Balloon time.
Alright, so the first one that we're going to do is rubbing this balloon for about, give or take 10 seconds, see how it affects the balloon here. And the second time around we'll do it for a minute, and then I'll have a colleague explain the law of charge and the triboelectric effect. So this one's about 10 seconds. Let's see. very slight, but you can kind of see them getting attracted to the other, especially if I take it away. So that's 10 seconds. So my colleagues are going to explain the law of charge and the triboelectric effect while we run for a minute.
Well, yeah, the law of charge ain't gonna be that. Ain't gonna be that like difficult to say. It's like the like charges, like the positive and the positive, they're gonna repel, and if they're like in the my bad.
You're good.
So the law of charges is just it's so simple. It's like the opposite signs, they attract each other, but if they're the same sign, they just repel. That's all of the law of charge.
For the triboelectric effect, it's essentially kind of the same thing. It's when two materials touch and then they either separate or they come together. Electrons can transfer from one material from the other. So in this case, one balloon's going to be charged and it'll be passing electrons onto the other one. That's what causes them to attract to each other. And when the material loses electrons, that's when they will repel. That's essentially the triboelectric effect and the law of charges.
All right, we've been rubbing for a minute.
As you could see, they're distracting.
Maybe a slight difference, but
experiment and also a video that you need to watch. So go there and see everything that's published for next week. Okay?
ultimately it seems pretty similar from 10 seconds to longer,
Yeah.
but maybe slightly more with more rubbing. But chances are that's due to the material, with it being rubber, very non-conductive, as opposed to if we put this balloon up to like a metal balloon that we have in class, chances are the effects we hypothesize would be a lot more intense, I guess. So.
All right, that's our presentation. Thank you. Bye.